Hello, we're going to look at topic 5 again today. So carrying on with topic 5, we're going to look at 5.3, 5.5 and 5.8. So really it's about observing the night sky, taking account of where the planets are, how they appear to move in the night sky. So what's their positions over a night, what's their positions over a few months, how does that change, how do we spot that they're planets and not stars. You've got this idea of retrograde motion, which is really important. There's a couple of videos for you to watch on that, but I'll try and explain it. It's easier with the videos really. And then 5.8, you'll see there's 5 terms there: conjunction, opposition, elongation, transit, occultation, which we'll look at in this video as well. Okay, so this is the first thing, retrograde motion. Now, planets were called, well, planet translates into wanderer. And you see all the stars, they seem to follow the same path every night in the sky. So over a 24-hour period, they kind of do a circle around the North Star, the Polaris, the pole star, or they will, rise in the east, set in the west, similar to what the sun does and what the moon does if you're looking south. So they all seem to follow a pattern. But there was a few bright things in the night sky when early astronomers looked that didn't follow that pattern. So over time, over days and weeks, they'd seem to move one direction across the sky, maybe to the left, and then they come back on themselves and then they start moving to the right, and then over days and days and days they gradually move over to the left. So you can see this here, observed over, this would probably be a number of days between each observation. It's here, then it's here, then it's here, then it's here. So it seems to follow the path. This is a logical path, isn't it? And then it comes back on itself. So moving back on itself is called retrograde motion. So that's what made the planets stand out from all the stars. Remember, Venus is very bright in the night sky, Mars is pretty bright in the night sky, but there's planets that are not very bright in the night sky. So it wasn't just that they were bright, it's the fact that they all have this kind of strange motion, retrograde motion. So it was a while till we had explained retrograde motion, but because they were wandering their way across the sky and didn't follow the patterns, they got called wanderer, which is translated into planet. Okay, so this is why you get retrograde motion. Think about Mars outside of the Earth. So the Earth is closer to the Sun at all times than Mars. So when you're here, you would look at Mars there, and you'd see it there. But you're comparing it to a background. So let's say all the background of all the stars, you'd see Mars. You can't tell that Mars is closer, so it would just look next to the stars around here. Fast forward, next thing you're here, Mars has carried on its orbit as well. But we're closer to the Sun, which means we feel a bigger force, so we're going faster around the Sun. So it's carried on, and then it appears here. So it's moved across the sky. Next, we're here. And again, it's kind of moved across. You can't tell it's further back, so it's gone there. It all seems pretty logical. But then we kind of start to lap Mars. And now our line of sight, Mars appears here against the background of stars. So Mars has come back on itself. Fast forward again, we're here. And then again, it's here. So now it's gone back to go in the way it was originally going. That's a retrograde motion. It will be explained really nicely in these 2 videos. Brian Cox does it, and you can see another video there as well. So I know it's something that crops up in a few topics, but it's a really important thing to get your heads around. Okay, next is this important idea of the ecliptic plane. And the ecliptic plane is the imaginary line drawn from the Earth to the Sun, and then just carry it on either side, and that's the ecliptic line or the ecliptic plane. Now, while no planet other than the Earth is exactly on it, they're all pretty close to it. Now, if we wanted to look from Earth directly towards the Sun and then the other way, I suppose, and to the left, imagine this ecliptic plane goes around in a circle, then it would appear where this orange line is. So it's not always a straight line running across the sky, because the Earth is at an angle, it's tilted, it's on an axis. So this is the ecliptic plane, which you can see on Stellarium, and this is an image taken from Stellarium, and we will have a little look at Stellarium in a few minutes. So if you look closely, you'll see that Saturn is on the ecliptic line. We've got Jupiter here, we've got Mercury, we've got Mars, the Moon follows it as well. So everything in the solar system, if you want to look and find it in the night sky, it's going to be somewhere along this orange line. If only there was an orange line you could turn on in the sky, it'd be very easy to find the planets. So that's stellarium. The shortcut for putting the ecliptic line on is pressing the comma on your keyboard, so it would be good to see, and then you can fast forward time and look at how they appear to move across the sky. Another thing that's quite important to notice is if you're looking for Mercury and Venus, they're always going to be very close to the Sun, but we'll look at that again when we open up stellarium. Okay, so that's the ecliptic line, and there's an ecliptic line which can be drawn across the sky, which is just how we view that line from Earth. It's doesn't seem to follow a straight line, as I said, because of the Earth's axis. Right, so we'll revisit that on stellarium in a minute. Now, we're going to look at some terms now. So this is the solar system from above, I suppose, if you went up from, close to the north kind of side of Earth and went up and looked down on the solar system. This is it. They've not made any effort to put it to scale or anything, so it's just to help me prove this point here. So Mercury, Venus, Earth. So we have two planets which are closer to the Sun. They are inside of us, and those would be called inferior planets. They have a lesser distance from the Sun. The planets outside, all the other planets are outside, so further away from the Sun than we are, so those are called superior planets. Okay, so there are two inferior planets, and then there's 5 superior planets. Now, the inferior planets are only ever going to be, right, imagine this is the line of sight. Here's the Earth, I'm going to look at Mercury. So as I look along, I would pretty much in the same line of sight see the Sun and see Mercury. They'd appear very, very close. What if Mercury was here? Well, then it would appear right in front of the Sun. What if it was here? Well, we could say, okay, it's really far from the Sun. It's not. Something over here would be really far from the Sun. Actually, this point here, not there, it's not a right angle. That would actually look a bit closer. It's this point here. Draw a line, and the line that could be drawn furthest away from the Sun, take Mercury to that position, and that's when it appears at its furthest from the Sun from our line of sight. It's not further, but it just appears further. So that point there, when Mercury is there, there's one on the other side as well. You would draw a line and try and just draw a line that doesn't come inside that circle. That will be the point of greatest elongation. Mercury appears furthest from the Sun. Venus would have 2 points as well, so bring Venus around here. That point here is a point of greatest elongation, and this point here is a point of greatest elongation. So that's only relevant to the two inferior planets. They both have 2 points of greatest elongation. Okay, and they can be measured with an angle here. So that's always going to be quite a small angle, so they always appear fairly close to the Sun, which isn't great if you want to observe them. So of course the Sun is very bright and you can't see them in the day when the Sun is up. So if the Sun is up midday, it's at its highest point. Venus and Mercury are close by, but you can't see them because of the atmospheric effects. So you have to wait, really. Venus is only visible, the same with Mercury, very close to sunrise and very close to sunset. All the others you can see at any time. Okay, next we will deal with conjunction. So conjunction is when two things appear to be close to each other. Now don't forget, there's a big difference between being close and appearing close. But if I was to look at, along here, and I was to look at the Sun, and I was carry on, and I would see Venus there, we would say Venus and the Sun are in conjunction. They appear to be next to each other, but they're not. Just, if you see somebody in front of you and then there's somebody 500 yards behind but on the same line of sight, you'd work out that one person is further away. But with astronomy you can't do that. Your eyes can't pick up the distance, so they would appear next to each other. So right now on this model, as we look, then you've got Jupiter and Saturn, which would be close. If we just take Saturn back to there, they'd appear to be in conjunction. Some planets, you could have it the other way around, where it's not necessarily at the closest point, because you could have Mercury here, couldn't you? And you could have Venus here. And as you look, they'd be in conjunction. They're not as close as when they're there, but they'd still look in conjunction, because our line of sight, we'd see two dots in the sky which would be very close to each other. Okay, so conjunction occurs when you're able to see planets very close to each other in the night sky. And as I'm speaking now, in December of 2020, there was Jupiter and Saturn had an incredibly close conjunction in the sky, which was very well known there. Okay, so that's when two planetary objects appear very close in the night sky. That's conjunction. Next is opposition, which is, if you think about we're comparing it to the position of the Sun, then opposition means it's in the opposite side to the Sun. So let's look at the Earth and let's take Jupiter. So if Jupiter was in this position here, let's leave the Earth where it is. So let's take Jupiter to here. Then as you look, you would see the Sun and you would see Jupiter pretty much along the same line of sight. So we would say that Jupiter is in conjunction with the Sun. But of course Jupiter could very well be back here. So you would look directly at the Sun, and then 180 degrees away will be Jupiter. So that's when it's at its greatest angle from the Sun, and that will be referred to as when it is at opposition. So really we're talking about opposition to the Sun. So opposition when it's at the opposite side to the Sun. There we go. So the Earth, here's the Sun, and then there's Saturn at opposition there. Okay, the next term is transit. Now, the most famous transit is Venus. But if we come back here, as Venus gets between us and the Sun, here's Venus, as it gets between us and the Sun, it's not exactly on the ecliptic line. So like we don't have a solar eclipse every month, or every lunar month, it's because it's got to cross the ecliptic line at exactly the right point. So it's quite a rare thing. But Mercury and Venus, the only two planets, they're the inferior planets, they can get between us and the Sun. None of the other planets can get in between us and the Sun. So they can go in front of the Sun. Now then, they don't appear as big as the Moon, so you're not going to see an eclipse, but you will see a little black spot on the Sun, which would be Mercury travelling across it, or Venus, the most famous of which being Venus. So this is a transit of Venus, you can see here, so it only appears pretty small. Transit of Venus is famous for a couple of reasons. I mean, there was a transit in 2012, which I've linked a couple of videos to, and you can watch that. And there was one in 2004, I believe, and I'm afraid they don't happen all that often. So you have an 8-year wait from one to the next, and then you have to wait about 120 years. So it only happened recently, the two of them, in 2004 and 2012. So I'm afraid we've got about another 120 odd years to wait till the next one. So yeah, if you didn't see it then, I'm afraid you've missed it. But it's a pretty spectacular thing to see, and the satellite images are stunning of it, I think, because it gives you a scale almost to Venus. It's a planetary object moving in front of the Sun, and I just think those satellite images are wonderful. But yeah, anything can transit anything else. It's when a smaller body passes in front of a larger one. So it doesn't block it out, that would be an eclipse, but it passes in front of it, so that would be a transit. And as you may know, when we're searching for exoplanets, that's planets outside of our solar system, it's very helpful when they transit their own star, so we can see the transit, so the light from their star dims slightly, and that's how we figure out that there's a planet there lots of the time. Okay, so that's a transit, and there's the definition there. And there's a beautiful video, I think, of transit of Venus. Now, interestingly, Captain Cook, you may have heard of, stumbled across Australia. He was sent on a mission in 1768 when there was going to be a transit of Venus, and his job was to sail to Tahiti, which was on the map. Australia wasn't at that point for the Europeans, and set up an observatory there, make friends with the locals, set up an observatory, observe the transit of Venus. He was sent south, someone else was sent north. They were going to compare the times it started and ended, and from the difference they could work out some clever angle, and then that would allow them to work out the scale of the solar system. But finding Tahiti, which is a pretty small thing, was a pretty big ask for Captain Cook. But yeah, so he's famous for many other reasons. But a lot of people don't realise, the mission was to observe the transit of Venus in 1768. Okay, and the last one is occultation. Occultation is a special event that will occur when a smaller body passes behind a larger one. So it's the opposite to a transit, really. Instead of something moving in front of something else, it moves behind it. And there is the occultation of Saturn by the Sun. So occultation, there's a couple of videos here, so you can see it happening behind the Sun, but it doesn't have to be the Sun. The occultation of Saturn by the Moon there is another nice video to watch. Okay, so if I now take us to Stellarium, and then I just want to use this to show a couple of points. It's a wonderful free program, Stellarium, and try and get this downloaded, and then you can have a play around with it. You can turn off the ground, which allows you to see the full ecliptic line. As I said, if I just press the comma now, that'll turn the ecliptic line off and then bring it back on again. So I'll bring the ground back on, but you can see here we've got this ecliptic line, and Mercury, Venus, both visible, very close to the Sun as ever, and Jupiter, Saturn there. And you can see as we fast forward time, so we're looking south here. There we go, Sun at its highest point, that's directly above south. We'd call this imaginary line that runs through south and up would be called the meridian line. So when something crosses the meridian, here comes Mars crossing the meridian, it's at its highest point. And that's the best time to view something in the night sky because it's the furthest away from all the light pollution. Okay, so we're looking south and everything seems to be going across this ecliptic line. Now if you press F3 or just go to the search window on the left there, press Mars here, and it will take you directly to Mars, and you can find the planets. So you could do it planet by planet, and if you wanted to find Neptune, it's under the Earth. Turn the Earth off, and there's Neptune. Shall we zoom in on Neptune here? So let's there it is. If you didn't believe me, there's Neptune. Isn't that cool? Okay, let's zoom back out. Now what I've done here, I know I've turned off the Earth. I've turned off the atmosphere. If you turn the atmosphere back on, you'll notice that it does day and night. Obviously you can't see a lot in the day. To level that floor again. So it takes a bit of getting used to, but not much, I would say, Stellarium. And it's just to show you that what the motion of the planets, they will always be found on this ecliptic line. Now this ecliptic line doesn't stay in the exact same point. You can see as a fast forward day by day here, you can see the ecliptic line kind of has a shimmy to it. But at any one point, if I freeze time and look for any of the planets, turn off the atmosphere, turn off the Earth, Jupiter, Saturn, you just keep going round and you'd be able to find there's the Moon, there's Mercury, Venus, always close to the Sun, there's Uranus, there's Neptune, Jupiter, Saturn, there we go. So Stellarium is really good for visualizing these things, and what's even better is actually going out in the night sky and trying to find the planet yourself with Google Sky and just try and locate them, and you'll see that they're always along this kind of line in the night sky. Alright, I will leave it there for today. Thanks for listening.